Hello, students, and welcome to Flintastic Chemistry. I'm teacher Mr. Flynn. Today we're going to be talking about the strong and weak nuclear forces. So I want you to write down this definition for a strong nuclear force. Okay, is the strong nuclear force is an attractive force that holds quarks together to form protons and neutrons, and holds neutrons and protons together within atomic nuclei. So let's make sense of what this definition means, because it's doing two things. Okay, the strong nuclear force. So I'm going to pull this book aside. I'm going to draw some pictures. Okay, so we've got a proton, and it's positively charged, and we have a neutron, and it is neutral. Okay, a proton is made up of two up quarks and one down quark. So these quarks, like we talked about in the previous video, are building blocks for protons and neutrons. And in a proton, we have two ups and one down. And in a neutron, we have one up and two down. See how there's just one difference? This one has two ups, this one has two downs. Okay, are we all right with this? All right. And the strong nuclear force is responsible for keeping these quarks together. All right. And forming what we would call the proton or neutron itself. Okay. So there's this strong force that's coming in here, pushing on these quarks so that they can form protons and neutrons. All right. Is this okay? This is our first part of understanding the strong nuclear force, and it holds quarks together. Okay. All right. And the second part of this is, I'm going to use the pictures in the book for this. Okay. It describes that it holds actually, I'll pull it right from the definition. It holds neutrons and protons together within atomic nuclei. So if you look at this picture here, we have a small, medium, and large atomic nuclei, or nuclei. And we've got this small atom here of just two protons and two neutrons, and it has a very strong force. It's pulling those neutrons and protons together very tightly together, very stable. Okay, helium is one of the most stable atoms we have. While as it starts to get bigger, as the radius increases on these nuclei, what we're going to notice is that the rate of decay increases as the atom gets bigger. That's because the strong force gets substantially weaker the larger it gets. So the larger the atom, the more likely it is to just fall apart and start decaying. And in the next video, we're going to talk about the different types of decay. But in this video, we're just talking about the concepts of strong and weak forces. And that strong force exponentially gets weaker as it goes out, as the radius increases. Okay, so keep that in mind. The larger the atom, the strong force weakens by a great amount. Okay, but when it's small, that strong force is pretty intense. Okay, so it does two things. It keeps protons and neutrons together, and it holds the quarks together of the neutrons and protons. All right, now I think that's all I'll talk about this. Okay, the weak nuclear force. So I want you to pause the video and I want you to write down these two definitions for the weak force and the beta decay. Okay, the force through which certain fundamental particles interact, resulting in some forms of radioactive decay, is the weak nuclear force. All right, so the word I want you to use is, or the idea is, it has the ability to cause change. Okay, the strong force holds it together, but the weak force can cause changes to occur. So if we look down here, right, our protons and neutrons are basically made up of the two same fundamental quark particles. Okay, and this neutron is going to have one of its down quarks turn into an up quark, and it's going to turn into a proton. And as it does that, it actually releases an electron. Okay, you don't need to know about these bosons or the antineutrinos. All I need you to care about is as it changes, there is this electron that is released. Okay, this is called a beta decay. Okay. Okay, the most significant of these happens during a beta decay, which is the type of radioactivity involving the conversion between neutrons and protons with the emission of a beta particle. Okay, and there's two types of beta particles, and they're electrons and positrons, and we'll talk more about those next time. Okay, but all I need you to know about this video is the strong and weak nuclear force. The strong force is what holds quarks together. Okay. It is what holds the protons and neutrons together, like as in this picture here. All right. And finally, the weak force is what can cause changes in neutrons becoming protons, and protons can become neutrons. Okay. Chemistry's starting to get a little weird, right? We're starting to have these subatomic particles changing in and out of each other. And this is time. So it's referring to as a process that happens. Okay. And it releases these beta particles. Okay. Or I would say a beta decay. Okay. All right. Till next time. Thanks for watching.